Okay. Section 6.3, logarithms and logarithmic functions. These words, logarithm and logarithmic function, will be new to you. Okay, this is a new idea. But in this section, we're going to define and evaluate logarithms, use inverse properties of logarithmic and exponential functions, and we're going to graph some logarithmic functions. Okay. So first, to get the idea of where logarithms came from. Okay. So we're able to take, let's say, 2 to the second and get 4, okay, and 2 to the third and get 8. But what power can I take 2 and get 6? Like 2 to the what equals 6, okay? So this was an idea that popped up, and we're like, well, how do we treat things like that? And we need a way of actually undoing our exponential equations. So that's where we came up. That's where they decided to come up with this idea called a logarithm. Okay. So the definition of a logarithm comes as follows. Okay. If I have an exponent, base b to the x, and it equals y. Okay. So I can actually rewrite the same relationship as a log. So it would go, you would write the word log, L-O-G, and then you denote the base of this exponent becomes a subscript. So you write it in little letters, base B. So you write it in just a little letter down below in the bottom right-hand corner of the log. Log base B of y, see where y came from, equals x. Okay? And I want you to notice here that here is my x here. Here is my x here. So I always like to remember log equals exponent. A log is just another way of writing an exponential relationship, but it equals the exponent. The exponent in my exponential equation now becomes what it equals in my base equation, in my log equation. A log is just another way of writing an exponent. So here we can write these logs. We have all these log equations, again equals. I can rewrite all these log equations as exponents. Okay. So here we have log, and how we would read this is I would say this log base 2. This would be written as in words. We would say log base 2 of 16 equals 4. Log base 2 of 16 equals 4. So this is my base. So to write this as an exponential equation, base 2, it equals the exponent and then equals the 16. So 2 to the 4th equals 16. This and this are what we call equivalent equations. They mean the same thing, it's just different ways of writing them. 2 to the 4th equals 16, log base 2 of 16 equals 4. Same thing. Okay, so here we have log base 4 of 1 equals 0. So there's my base 4, there's my exponent, the 0, and it's going to equal 1. Because 4 to the 0 equals 1. And a little refresher, a reminder, if we don't remember, anything to the 0 power is equal to 1. So anything to the 0 power is 1. Okay. So now we have log base 12 of 12 equals 1. So there's my base right there, 12. There's my exponent, 1 equals 12. Well, yeah, 12 to the 1 equals 12. Just like 2 to the 4th equals 16. 4 to the 0 equals 1. 12 to the 1 equals 12. Okay, so it's just different ways of writing it. Okay. So same here, here's my base, negative 1 equals log base 1/4 of 4. So here's my base 1/4. So there's my base. Here's my exponent, negative 1 equals 4. So 1/4 to the negative 1 equals 4. And it does, because this is going to take the reciprocal of 1/4, which is 4. Okay. So there's writing from log equation to exponent equation. We're going to be doing that a lot to help us solve and simplify our logs. Okay. This next one here, these are all written in exponent equations, exponents with our powers. We're going to rewrite them in logs. So we write log base, look here, what's my base? Base 5 of 25 equals 2. Because again, remember, a log equals the exponent. So here we need to equal the exponent of 2. Okay. Now this next one, log base 10 of 0.1 equals negative 1. Because again, a log equals the exponent. There's my exponent part, and there's my base. Okay. Now 8 to the 2/3 equals 4, so we have log base 8 of 4 equals 2/3. Okay. Okay, so there's my base 8 of the 4 equals 2/3, because again, a log equals the exponent. And then this next one, log base 6 of 1 over 2/16 equals negative 3. Okay. So it's important to know, so you see I put parentheses around this, this is not a multiply. Okay. This right here, this log base b, this is not a multiply. Is not a multiply. It is taking the log of a number. Okay, this log is an operation. It's something we're doing to y. Okay, so if I want to do this log to the whole 1 over 26, 1 over 2/16, I need to put it in parentheses. This is telling me I'm putting this entire thing into a log that's base 6. Okay, all right. So we have our two most basic logs to evaluate is a logarithm of 1, because we know anything to the 0 power is 1. So if our reminder here, anything to the 0 power is 1. So let's use, instead of an x here, sorry, let's use a b. B to the 0 power, base, any base to the 0 power is 1. So to write this as a log base b of 1 equals 0. Okay, so whenever I take the log of 1, no matter the base doesn't matter, this could be any base. Whenever I take the log, whatever base of 1, we always get 0. Because of this idea, b to the 0 is always 1. Okay, so if my base and my what it equals match, because think about anything b to the first power, anything to the first power is just itself. B to the 1 equals b. So if I was to rewrite this as a log base b of b equals 1. So if the base and the number you're taking in the log of match, okay, so if we have this matching idea, so if the base, okay, matches what it equals, then it's going to equal 1, because b to the 1 equals b, and it comes from this idea, b to the 1 equals b. Okay, so the simplest way to evaluate logs is to actually rewrite them as exponents. Okay, so here I'm trying to find log base 4 of 64, and I want to figure out what does this guy equal. So we're trying to figure out what this equals. So I'm going to say, okay, let's say it equals some number x. Now that I have it equaling x, I can use the same tricks we did up here to rewrite this log as an exponent. This is telling me 4 to the x equals 64. So now my goal is to find 4 to the what is 64. So let's see, let's try some numbers. 4 to the, it's not 4 to the second, what about 4 to the third? 4 to the third. So that tells me that log base 4 of 64 equals 3. Log base 4 of 64 is 3, because 4 to the third is 64. Okay, some might require a little more extra work, like in this next one. Log base 5 of 0.2 equals something, x. So now that we have it equal to something and a log base 5, we can go ahead and again use our converting. We can convert it to an exponent. So 5 to the x equals 0.2. Well, you could just try a whole bunch of random decimals and hope something works out. I would highly suggest against that. It's going to take you forever. Hey, or we could try to figure out, do a little bit of work here. So let's go 0.2. What is 0.2 as a fraction? Math, enter, enter. It's 1/5. So here we have 5 to the x equals 1/5. So now I want to try to write this as base 5, because we're base 5 over here, base 5. So 1/5, that's a reciprocal of 5. So this is 5 to the negative 1 is 1/5. If you're not sure, try it. 5 to the negative 1 is 1/5, 0.2. Okay, equals 5 to the x. So that tells me that this x had to be negative 1. Okay, so log base 5 of 0.2 is negative 1. Word of caution here. Some of us really rely on our calculators. Okay, they really aren't going to help you out much here, just so you know. Don't use, and we'll look at these 2 buttons later. There's a log button on your calculator right here. It's what, 1, 2, 3, 4 buttons above log, okay? So 3 buttons above on. Okay, so don't use that one. We'll talk about what it means here in a minute, but your calculator can only handle certain types of logs, okay? So be careful. Don't use those. So next one, we have log to the 1/5 equals 125. So we want to figure out what this equals. So that equals something. So we'll go 1/5 to the x equals 125. So now here's what we need to do, a little bit of some exponent magic. Basically, we write stuff using exponents. Okay, so here 1/5, I don't like that fraction, but we know 5 to the negative 1 is the same as 1/5. So I'm going to replace this inside here with a 5 to the negative 1, but it's still to the x power. Okay, so then now, a power to a power, I multiply the exponents. This would be 5 to the negative x now. So now this is base 5. Can I write 125 base 5? So let's try it. 5 to the second, nope, 5 to the third, 5 to the third. So this 125 is 5 to the third. So then I know here I have negative x. I have 5 to the negative x equals 5 to the third. This will only be true if negative x equals 3. Negative x equals 3, which means that x would have to equal negative 3. So there's my answer, negative 3. So let's double check. Let's take 1/5 to the negative 3, right? I'm going back to this original problem right here. 1/5 to the negative 3, and let's see, do I get 125? Oh, we do, it worked. Yay! Okay, right, next one, we have log base 36 of 6 equals something. So now we have 36 to the x equals 6. Okay, this is base 36. That's not very pretty. This is a 6, but I can see a way that 6 relates to 36. 36 is 6 to the second. That's 36, but that's still to the x power. So now we have 2 times x, so this would be 6 to the 2x equals 6. But this is just 1 6, so that's 6 to the 1. So for these two to be equal, 2x has to equal 1. Divide both sides by the 2, and we end up getting 1/2. So let's double check this. 36 to the 1/2 is 6. Because remember, to the 1/2 power, this 36 to the 1/2 is the same as the square root of 36, and that does equal 6. Okay. All right, so now to talk about some things that might allow you to use logs in your calculator. Okay, so I talked to you a little bit about that log button in your calculator. You have this log button and actually this log below it. Okay, is also a popular button. Okay, there's 2 types of logs we use the most often. One of them is log base 10. We use it so often that we give it a special name. We call it a common logarithm. So if I have a log base 10, we call it a common log. So log base 10 of x, okay, base 10, we use it so often that we drop the 10, meaning we don't write it. We would just write this as log of x. So if there is no base here, so if there's no base written, assume it's 10. Okay, so if there's no base there, assume it's 10. So if they just have like the log of 5, okay, it's base 10. Okay, that's the most common logarithm. Okay, so in your calculator, this log button here, if you were to type it, log, if you notice it has no base. Since it has no base there, it's assuming it's 10. Okay, so your calculator can really only handle log base 10, okay, with the log button. Okay, there's another log that's used so often, and that one we call the natural logarithm. It's base e. Remember that number e we talked about in the last section? Okay, we use that as a base a lot, so we also, again, have a really common, it's what we call the natural logarithm. Okay, so log base e of x, again, is used so often that we shortcut this up, and instead of writing log, we write ln of x. Okay, so ln of x stands for natural log. I don't know why they didn't go nl. Maybe because I wanted to start with L like log does, but this stands for natural log of x. So since it's natural log, it's base e. So when you see this ln of x, that's base e. Okay, it uses that base e number, and if you don't remember from previous section, e is approximately 2.718. Okay, and if you notice on your calculator, the ln button right here is the e to the button. Same with the log button. The log button is the 10 to the x button. So base 10, base 10. Base e, base e. Okay, I do that for a reason. Okay, so we can actually, if we're base 10 or base e, we can actually evaluate these pretty quickly in our calculator. Like if I wanted to find the log of 8. Again, don't lose track of what this is looking for. This is really asking, this is base 10. 10 to the what is 8? Okay, so do you agree it's got to be smaller than 1? Because 10 to the 1 is 10. Okay, so, and I can actually find that approximate number by typing in log of 8, and we get 0.90. And it says to go to 3 decimal places, so 0.903. So the log of 8 is approximately 0.903. Again, we decided it was going to be less than 1 because 10 to the 1 is 10. Okay, now we have the natural log of 0.3. Again, e to the what is 0.3. So let's see, e to the what is 0.3. So natural log of 0.3, we get negative 1.204. We need to do approximately because we're rounding. Negative 1.204 if we go to 3 decimal places. Okay. All right. So now we have our inverse properties. Okay. How inverses work is, again, they undo each other. Okay. So if my bases are the same, okay, meaning if I have log base b of b to the x, and I'm trying to figure out what it's equal to. Basically, it's asking me b to the what equals b to the x. Well, that only works if this question mark, in fact, is an x. So what we like to think is these undo each other. Log base b of an exponent base b. The log base b and these exponents undo each other, and I'm just left with the x. For example, log base 3 of 3 to the 5th. I don't even need to work this one out. We're base 3 here, base 3 here, so the log base 3 of base 3 to the 5 is just going to be equal to 5, just equal to that exponent. Because this base 3 and this base 3 undo each other. Okay, that also works for exponents. Meaning, if I have 10, okay, and I'm taking it, if I have base b, and in my exponent, I have a log base b of x. So exponent, basically I have a log within my exponent. So this is up in the exponent. This guy here is up in the exponent. So I have b to log base b of x. This b, base b, and this base b undo each other, and we're just left with x. Okay. So if I have 5 to the log base 5 of 4, well, this base 5 and this base 5 undo each other, and we're just equal to 4. Okay, so here on this example 5, 10 log of 4, 10 to the log of 4. Again, this guy here is the exponent. Okay, and this is a log with no base, so that tells me it's base 10. So we're base 10, base 10. This guy's just equal to 4. okay, because they undo each other. Sometimes it might require a little bit of work because these aren't the same base. This is base 5, this is base 25, but I can rewrite 25 base 5. I'd have log base 5, 5 to the second is 25. So I have log base 5 of 5 to the second to the x. I just replace this with this. Now a power to a power, we multiply those exponents. Log base 5 of 5 to the 2x. So log base 5 and 5 undo each other. This guy is just equal to 2x. Okay. So we can actually use this idea that exponents are logs and logs are exponents to actually find the inverse of exponential functions. We can also use it to find the inverse of log functions. We use this idea that every exponent can be written as a log, okay, and every log can be written as an exponent. So when we found inverses before, what did we do? We set it y equals 6 to the x, and then we flip-flopped the x and the y, right? We do the same thing. We want to switch our x and our y. So we do that same thing. So x equals 6 to the y. So this is in fact the inverse, but you know we like functions to be y equals. So I need this as y equals. So what I'm going to do is I'm now going to rewrite this as a log. So it's going to be log base 6 of x equals y. So just rewriting it as a log, now set it equal to y. So now there's my inverse. So since this is an f of x, we want to write this in f of x. So f inverse of x is equal to log base 6 of x. Okay. All right, so same with this one, but we need to know this is now a log. If we don't remember, this is natural log, so this is base e. So I'm going to start by writing that as base e, log base e of x plus 3. Okay. Now over here I'm going to switch the x's and y's. X equals log base e of y plus 3. Okay. And now, so this is the log base e of y plus 3. I'm now going to rewrite it as an exponent. So we're going to rewrite as an exponent. So base e to the x equals y plus 3. So we have e to the x equals y plus 3. Again, our goal is to solve for y, so I'm going to have to subtract 3 from both sides. So my inverse is going to be e to the x, subtract 3. So there's my inverse. Y equals e to the x minus 3. This is a y equals, so we can leave this one as a y equals. So there's my inverse. This function and this function undo each other. Okay. All right, we have one last thing to talk about, and that's graphing logarithmic functions. I'm out of time right now, so I'll go ahead and attach that video on here in a minute.